So welcome back to my YouTube channel. So today is day 8 of problem solving 100 days challenge. So today the problem is rotate array. So here what we will do, we will rotate array to right by k steps. Input, suppose we have given array 1 to 6 and k is equal to 2 steps means like we have to shift all the value to 2 steps right. So 1, if you will shift right to 2 step, it will come here, and 2 3 4 like this. So in this video we will see the brute force approach and optimize solution, and at the end we will try to solve in a LeetCode. So let's get started with this video. So brute force approach will be here. What I will first mention you that what will be the main idea for the brute force to solve this problem. So rotate the array one step at a time and repeat this process k time. Each time we will rotate the array one step at a time. K times means if k is equal to 2 times we will repeat the process. What will the process? First target will be, we will going to store the last element at a first, and we will shift all the element to right by 1, and at the end whatever the last element we will store in a first. Means like I'll show you with the visualization. Suppose if the k is greater than 9, we can take at the time k mod n. Means if k is greater than n, means suppose our length is 5 and k is 6, or length is 4, k is 6. So whenever time at the time if it is greater, then we have to take the mod 2 to make it come within the range of that length. So suppose in first rotation 2 times we have to rotate. First rotation, whatever the last element it is 6, so 6 we will store in last, and then each element we will shift to right position. So 5 we will shift to right position in first loop, then 4 we will shift in second, then 3, then 2, then 1. At the end it will look like this, like all the 1 2 5 it will shifted to right and 1 is repeated. So in this position we will going to store the last element. So in the first traversal all the element shifted to right position by 1, and again same thing we have to do. We will store the 5 and each element we will shift to the right, and then last we will store the 5. So like whatever see in starting the last element we are going to store in a last variable, and at the end we will store in a first position. So each time, first time means k is equal to 2, the first time each element will shift to right, and last element we will directly assign to the first position. In second time also last element, each element will be moved one step back and last element will be shifted to first position. So basically we will store the last element and we will store in a first each time when we are looping. So suppose k is equal to 2, so 2 times we have to do. So let's start the coding, then only we will able to get the clear picture of this. So I'm going to solve in a VS Code. So in this VS Code I have a given main method. Here the array is 1 to 5 6 and the k is equal to 2 is the original array, and then after that original the rotated array. So first I'm going to pass a rotate method. That method will, that is void method, that will not going to return anything. So here we will pass and we will rotate. So let's start the coding. So first what we will do, we will calculate the length of that array. Then when we done that length of the array, and again we will do, suppose our k is greater than n, at that time k mod n we have to do to bring it within the range of that length of that array. Fine. So if k is equal to 2, so 2 times we have to traverse. Like if k is equal to 2, first rotation and then second rotation. Here, second rotation. So what we'll do, we will basically write one loop for traverse. First rotation will be int I is equal to 0, I is less than k, I plus plus, and each rotation we have to take the last element and we have to store in a last variable. Then at the end what we will do, we will store in index 0 directly. So what will the length of the length is n, and n minus 1, that will give last index position, and nums will give that value at last index. So till here it is fine. Now we have to shift each element to the right position. Like 6 we have stored, right? Now we will shift each position to the right, 5 6. So basically we are going to write one more for loop that will shift all the position to the right. So here what we will do, we will take int j is equal to n minus 1, and j is greater than equal to 0, j minus minus. Fine. So take grade is equal to 0 only, not equal to 0, because in the 0 position we are going to store our last element. So till here it is fine. Now what we will do, we just nums of j, we will assign the value of nums of j minus 1, means opposite we are going, right? Suppose the index here, this index is 0 1 2 3 4, it is index 4. So whatever j minus 1 will means 4 minus 1 3, if it is 3, then it will store to this 4 position. So each time one element will lift to the first. If the j is 5, at the time nums of 5, so here 5 will become 6. If the length of the array is 6, so here it will become j is equal to 5. So nums of 5 will be nums of 4. The nums of 4 value will store in nums of 5. So each time each element will shift to that right position, and after this what we have to do, we directly store that starting position, the last element. So we almost done this. So each time what will happen, last element will store in a last variable, and after shifting all the value it will look like this. 1 3 3 5 means if this inner loop will complete at the first round, so it will look like this: 1 1 2 3 4 5. So last element we have stored, we will directly assign to the first position. So after first round of k1 shift, it will look like this. Initially what is the given array? 1 2 3 4 5 6. So 6 came to the first position and everyone shifted to the right by 1. So same thing in the second steps also it will do, and it will 6 will come here again, right position, one step right. So at the end 2 step it came. So this is the brute force. Here we are using 1 is for k outer and inner is equal to n. So n into k times. So suppose if k is bigger, so it will become n into k times. So that is the time complexity, and space complexity we are not declaring any, we just O of n. So it will show in a one time only. So here what we will do, we will try to run this and we will check whether brute force is working fine or not. So fine. Here 1 2 3 4 5, and it is coming as a result expected 5 6 1 2 3 4. So we can check as much as edge case. So let's see what will happen if the edge case, if n is equal to 0 or k is equal to 0. So we can handle here edge case also. If n is equal to 0 or k equal to 0, at that time we can directly return from here. So fine, num is nothing, just nums dot length, or we can write this one after this length, and here we can write n. Fine. So suppose if k is equal to 0, we are passing, and we try to run. So here it is not doing anything directly, it is returning to that initial position. So if k is equal to 3, what will happen? So it will 6 is come to this position. So each time it is shifting to the right by k steps, right? So this is the brute force. Now we are going to see the optimized solution for this. So what is the optimized solution? So optimized solution, the basic funda will be, whenever the k is greater than n, we will do k mod n to bring within the range of that length of that array. Now we will reverse whole array, then we will reverse first k element, and after that k to n minus k to we will reverse last n k minus element, means first k element means 0 to k till, and then k plus 1 to till n. We will going to reverse like this. So let's see, I will say one example. Here k is equal to 2, so 1 2 3 4 5 6, we have a 6 element. So what we will do, we will first reverse all the element 6 5 4 3 2 1. Then first what we will do, after this reversing, we will reverse first two element, means 6 or 5. 6 or 5 we will, if we will revert, then it will show 5 6 and 4 3 2, it will look like this. Then after that we will reverse last 4 element. If we will reverse last 4 element, it will become 1 2 3 4 5. So see that our expected result, like it is shifted to one position right, two position right. 6 earlier, 6 was here, so one it will shifted, it came here, and again it shifted, it came here. So let's see the visualization of this code. Suppose we have given array and we have 2. So if 2 mod 6 means k is equal to 2 only. So if we will reverse whole array, first we have to reverse, when we are reversing whole array, our array will be look like this. Then first k index means 0 and 1, that is 2. So first two index will, if we will reverse, it will look like this. 5 6 5 become 5 6, and then remaining we are reversing 2 to 5, then it will look like 5 4 6, then it will look like this. So this is the basic idea. Now we will going to try to code for that optimize one. Actually we already have done one reversing array. We will just utilize that one reversing array method. Here we can utilize this one reversing array method in optimized solution. We will here just what we will do, we will here just use that, we will use that one. Why it is showing error? Try to make this as a private. We will use this here, left right we can pass, or we will pass the left right value. So here we are going to pass our left and right values. One more bracket is needed here. Fine. So we will going to write our main logic. So basic, like for the brute force, this will be the same only, like whenever we will going to take the length, and then we're checking the edge case, what will happen if k is greater than n is equal to 0, k is equal to 0, at that time we will directly return. So here what is we will do, we will use this method reverse, and we will try to reverse first all. So basically we will pass the array, then initial position and last position. What will be the initial position? 0 to n minus 1. Means first we are going to, here it is nums, sorry. So first we are going to reverse whole. So in the first we will reverse whole, and second what we will do, second we have to reverse first k element. Means 0 to k element means k is equal to 2, then till which index? K minus 1, that is till first index, and after that k to n minus 1. Fine. So here we almost done with this. Let's run this and we'll check whether it is working or fine or not. So here we are getting the result. If k is equal to 4 means 40 will 1 2 3 and 40 will come to first position. Here it is coming as expected, the result is coming as same. So I will repeat once more what I did in optimized solution. In optimized solution we first reverse whole array, then first k element and then last k element we have reverse. So first we will reverse whole, then it will look like this. Then first two k element 5 6 we reverse, 6 6 5 we have reversed to 5 6, then last element. So it will look like that right element k steps. So now we are going to, we almost done this. And what is the time and space complexity for this? So time complexity is OFN because we are using only this while loop, and here OFN space complexity, there is no k loops as in the brute force. Fine. Now we are going to solve that rotate array in a LeetCode. Same problem is there. If we have given 1 to 7 and k is equal to 3, so we just copy this and we will check in our local whether we are getting the same result as a, and here k is equal to 3. So 5 6 3 4 we are getting the same result. So we can copy this code and we will try to run in the this name is same as nums, here nums, and we will try to run this one and we will check whether we are getting the result or not. Yes, it is compiling. So all the test cases pass and we are able to submit this one. So I will repeat once more what we have done in brute force. In brute force we are just storing the last element and we are reversing each element. Like if k is equal to 2 to 2 times you have to traverse, k is equal to 1 times we will shift all the position to 1, again we will shift 1 position, but we will store last to the first index each time. We are doing like this. But what we did in optimized solution, in optimized solution we first reverse whole array, then first k element, then after that reverse the last and k element. So in optimized solution we are getting that time complexity, space complexity, OFN on OF1. So hope you like this video. Thank you for watching this video. We will come tomorrow with the day 9 challenge. Thank you.